Hey guys, it's Kodrosum here, and in this brand new series, we're going to be building a REST API with NodeJS and MongoDB. We're going to be building an e-commerce system with all the common features available in a real-world e-commerce system. And after the development, we're going to Dockerize it and deploy it to AWS. I'm going to teach you every single step from initializing the project until the deployment to a real-world live server. Sounds good? So let's get started. In this system, there are users, and the users are in two types, sellers and customers. Sellers can create a shop and add products to their shop, while customers can add those products to their cart. And finally, customers can purchase the products in the cart, which creates orders, and there will be order management as well. So it's a complete process from creating a seller and to delivering an order. We'll be learning how to develop every single module from start to finish, which includes sending emails, sending notifications, handling payments, and implementing a hosted search functionality like Elasticsearch or Algolia, and image management with AWS S3 bucket, and there can be more. Finally, we will Dockerize the application and the database and deploy to AWS virtual machine. So we will be covering a lot of stuff. Alright, so that's it for the introduction. So let's get started. Alright guys, so I have opened up my IDE, which is WebStorm, and let me open up the terminal. And let's initialize our Node.js project by typing npm init --y, and this will create a package.json file with the default values. Alright, so here is our package.json file. Well, I'm gonna keep this file as it is for now, and since we are developing this application with TypeScript, let's install TypeScript on our project. Npm install save -dev. Since we need this TypeScript package as a development dependency, we added this save -dev flag, and we need TypeScript, and also we need another package called ts node.dev. It's a development tool that automatically restarts our application whenever we make changes to file. So it's easier for us to use that package because we don't need to manually restart our application every time we change our files. It's also a development dependency, ts node.dev. Alright, so let me open up the package.json file as dev dependencies, our two packages have been installed. So what's next? Next, let's initialize our TypeScript project. To do that, I'm going to type npx tsc --init. Well, this tsc command is available because we installed TypeScript on our project. Hit enter, and it will initialize our TypeScript project by creating this tsconfig.json file in our project. So if you have no previous experience with TypeScript, this might be a little bit weird for you. By the way, this what this config file does is it gives some instructions to TypeScript compiler about our project. So for now, I'm going to keep this file as default, except I need to change one property, which is outdir. This one. This means the output directory of our compiled JavaScript files. So even though we develop our application with TypeScript, when we build our application, when we compile our application, these TypeScript files will be converted to normal JavaScript files, and inside this outdir folder, the folder that we define here, inside that folder, those JavaScript files will be saved. So I'm gonna type dist. So inside our project root folder, there will be a folder called dist, and the compiled JavaScript files will be saved inside that folder. So I just uncommented this outdir property and added this value. Alright, so I'm gonna keep the other values as it is for now. If you need some in-depth knowledge on this tsconfig file, check out my other video called TypeScript Basics, and it will give you some more information on TypeScript. I have included that in the description down below. Alright, so let's close this. Alright guys, so we initialize our Node.js project, and also we install TypeScript, and we initialize TypeScript, and now what? Now we need to install few more packages on our project. Since we are developing a REST API, we need something called HTTP framework to handle our requests and responses. To do that, we're going to install Express. So I'm going to open up terminal. I'm going to type npm install Express. Hit enter, and this will install Express. And also we need another package along with Express, which is TypeScript definitions for Express, since we are developing our application with TypeScript. Alright, let's type npm install, and it should be a development dependency dash save dash dev, and it should be types slash Express, and this will install TypeScript definitions for Express. Alright, so we installed Express and its TypeScript definitions. Let me open up our package, and as you can see, as a dependency we have Express, and as a development dependency we have TypeScript definitions for Express here in our package.json file. Alright, so now we have set up our application, and now we can start write some code. Alright, so in our project root folder, I'm going to create a new directory called, I'm going to name that src. So this is the source folder. This is where I'm going to put all my project files. Here, let's write our application file. I'm going to type app.ts. So this is our application file, and also I'm going to create another file called index.ts. So this is my server file. In our application file, let's create our Express application. So that's where the entry point of our entire application. I'm gonna import Express, just like this, and let's create a new application, const app equals to Express, and then let's export our application, export default app, just like this. Alright, so that's our application, and here in our index file, let's import our application. We just created just like this, and then we should make our application listen to a certain port. For the port, let's say I'm just going to hard code this port for now. We will add that in the environment variable file later, and let's have a callback function just like this. So if our application started correctly, let's add the console log. App is running on port 3000, just like this. So this is our server file. Now we can run this application. Let me open up the terminal. I'm just gonna clear this. Before running any commands, let me open up our package.json file, and here I'm going to add another script. I'm going to name that dev. So here I'm going to use this development tool that we installed, ts.node.dev, and I'm asking it to run my index file we just created inside our source folder, ts.node.dev src, just like this. So it will automatically detect my index file here. Alright, so now we can run npm run dev. So it will run this command. Hit enter, and it says our application is running on port 3000. Let's open up our web browser and let's type localhost and port 3000. Yep, it says our application is running. It gives me an error, cannot get this path because we haven't defined any routes yet. So our application is running. Alright, so as you can see, let me change something on this file. Our application is automatically restarted. So that's the beauty of this development tool, ts.node.dev. We just don't have to restart our application manually. Alright, so now we have a running application. Now we can start creating our project structure in our project. Currently we just have two files as our source, application file, and our index file, which is the server. Now we can start creating some folders to organize our project files. Alright, so since we are developing a REST API, we're gonna have a few directories like controllers, models, middleware, and also maybe routes. Yeah, let's create those directories. Alright, first let's create a folder called controllers. So inside this source folder, that's where I'm gonna put all my project files. Alright, so we're gonna have controllers. We use controllers to handle our requests and responses, and then we're gonna have models. This is where we define our database schema. Since we are developing this application with MongoDB, we're gonna have MongoDB schema inside our models. And then we're gonna have middleware. We use middleware to protect our routes. When a request reach a route and the route direct that request to the controller, between the controller and the routes we put middleware, so that we can make sure the user is authenticated or not. So if it is not, we can send a response that you are not authenticated. Otherwise, the user is authenticated, we can direct them to the controller and send them a success response. Alright, so that's where we use middleware. And also we're gonna need routes. Alright, so this way we can organize all my project files. Alright, so now we have some project structure, and inside our routes folder, let's create a route. So I'm gonna create a new route file. I'm gonna name that, let's say, auth.ts, because we're gonna define all my authentication routes that we're gonna define in the future inside this auth.ts route file. So here I'm gonna import express. We're gonna create a new constant called auth routes, should be express dot router, just like this. Alright, so here let's define auth routes dot, then the HTTP method. This should be a get request, and as the first argument we have to pass the URL, the path Yeah, for the path, let's say let's add some path, maybe ping or something. Here as the second argument we can pass a controller method or something like that, but since we haven't defined any controller yet, let's pass a callback function just like this. Here we can add request and response just like this. Inside this callback function, let's return a response, res dot then the status should be 200, which means a success response. And also we should have a JSON body, and here let's add a message. Message should be pong. So we can use this route to make sure the application is working fine. Alright, so now we have a JSON body as the response. Now we have to export this export default auth route just like this. Now we can simply import this route file to our application file. Let's import this, import auth routes, and this ID automatically imports that for me. Let's see, add app.use. Then we can maybe add a prefix or something, maybe API/v1. Then auth routes just like this. Alright, so let's open up our web browser and let's try hitting this endpoint, API/v1/ping. Yes, now we have a JSON response saying this message we have added. So we have created our first route successfully. Alright, so one other thing that we should do here in our application is that we should configure CORS. CORS stand for Cross Origin Resource Sharing. CORS is a security feature implemented by web browsers to prevent web pages from making unauthorized requests to different domains. So we have to configure CORS as a middleware so that this API can only access from allowed domains. Alright, so to handle CORS, I'm going to install a new package. I'm gonna type npm install. The package name is CORS. Hit enter and it will install this package for me. Alright, so if you open up your package.json file, now we have another package called CORS. Alright, so now in our application file, let's import CORS. Just like this, and we need to install TypeScript definition for this CORS package. That's why this is showing me with this red underline. I'm gonna type npm install, and it should be a dev dependency --save -dev types /CORS. Alright, so now the error is gone. We have to use this CORS as a middleware. So before define your routes, we have to add this app.use and CORS just like this. So here inside this we can define some options. What are the allowed domains? What are the allowed methods? Also allowed headers. So I'm not going to define these options just yet, because throughout the development we are just using Postman as the API client. So these cores need to be configured only when we are accessing this API using our web browsers through with the front end. So we will configure this later when we are connecting a front end to our API. So for now, I'm just going to keep it like this. So it will allow any domain when we keep it like this. Alright, so now we have set up a route and we configured course and we have done pretty much. Now it's a good time to pay attention to the database connection. Alright, so before creating the database connection, let me show you the database schema that we are going to build. Alright, so this is the ER diagram of our schemas. Well, this is not a relational database because we are using a NoSQL setup like MongoDB, but still we can build relationships between entities. So to clarify this schema, I drew this ER. Let me quickly walk you through this setup. So here we have few collections, just like in relational database like MySQL we have tables. In NoSQL databases like MongoDB we have collections. Inside a collection we have a document. Documents is equal to rows in MySQL, I mean relational database. Alright, so here we have few collections. We have user collection, users collection, products collection, categories, carts, orders and payments. So these are collections. Alright, so inside the users collection, so this is the schema for a user document. Here we have the primary key, which is ID, and then we have the email of the user, then the password and the user type. Since this is an e-commerce system, we're going to have multiple user types. We're going to have customers, we're going to have sellers, and also we're going to have admins. So that's user type. And then we have this shop field. Inside this shop field we have name, description, and also display photo, cover photo and address, and also this contact number. The benefit of using this NoSQL setup is that we can define any number of nested objects. Here we have name, address, phone number, gender, and birthday. And then we have a few other fields like email verified to make sure the user is verified the email, and also we're going to have email verification code, make sure the user has verified his email, and then the user status, maybe he's deleted or something, or maybe he's blocked or something. We can handle that with this field. Alright, so that's user schema. Then we have product schema. Users can add products. We're going to have a separate collection for this product schema. Of course, we can define products inside this shop field, but the thing is, a single document can only have a limited size. So when the user adds more products, there is a chance that this document can exceed that limit. So that's why we define a separate collection for these products. For the products, we're gonna have ID, title, product description, and tags, and also product category, price, size, and also some other options like weight, and then user ID. That's where we keep the reference for this product, which products belong to which user, and also then the status. And as you can see, we have a one-to-many relationship between user collection and products, because user can have multiple products, and product belongs to only one user. And then we have this category collection where we define the category of our product. And then we have cards. Inside that we have the primary key, which is ID, and also user ID, and the cart status, and the items. Here inside this item we're gonna have an array. We're gonna have as many as products as the cart items inside this items array. So if you have done something similar to this using a relational database, you might need two tables for this, one for storing the cart and one for storing the cart items. But since we are using this NoSQL setup, we can create a nested array inside our document. So it's really easy to manage. And then we have some fields called subtotal and total. And after the carts, when the products are added to cart, then we have these payments. A cart can be processed with a payment, and then these orders will be created. And for the orders we have some unique IDs called UUID, and also cart ID, subtotal, service fee, delivery fee, and some other stuff like total, seller ID, and customer ID, and also this status, delivery status, and then the order items. So we will discuss these later when we are developing the particular module. So it will make more sense to you when we are developing it, when we are developing that particular module. Alright, so these are the collections. We're gonna have like 6 collections for now. Maybe there can be more. Yeah, let's see. So that's the database schema that we are going to use for our e-commerce system. Alright, so now we know what is the database schema that we are going to develop for our e-commerce system. And now we need a database. Well, you can simply install MongoDB on your local computer and create a database. Well, what I'm going to do is I'm going to run MongoDB as a Docker service. Well, you can simply go to official Docker website and install Docker desktop for your operating system. I'm using Windows, so I'm going to download it for Windows. I have already downloaded it, and it's up and running. So once the Docker desktop is up and running, you can simply search for the images that you are going to pull. So I'm going to type MongoDB, and there can be multiple results, and make sure you pull the official image. Yeah, I'm going to pull it, and it will take some time to download the image to your local Docker desktop. Yeah, it showed me the progress here. Alright, so I think we have pulled the MongoDB image. Now we can simply hit this run button, and it will ask me some configuration for the host port. I'm gonna type 270 and 17. So this is the default port for MongoDB. I'm just going to use the same port, and also we can define a volume here. Yeah, I'm going to define a volume here because it will save the database data in our local machine. Other values I'm going to keep it as default, and I'm going to hit run, and it will start the container. Yeah, inside this container section you can see your MongoDB is running with this port. Alright, Yeah, I have some other containers like RabbitMQ and some other application containers. Don't worry about it. Just pay attention to this record MongoDB latest, and it's running. Alright, so now we have our MongoDB server up and running. Now let's install a database client. So here I'm going to use a database client called MongoDB Compass. You can simply download it from their website. It's a free tool. So with that, you can simply browse through your databases and collections. It's very easier for us to when we are developing with MongoDB. So I have already downloaded it and installed it. So just like this, using our MongoDB connection string. So this is the connection string for my MongoDB server, MongoDB localhost, and the port, and we can simply connect. Currently we have these 3 databases which is created by default. All right, and yeah, so now what? Now we need to connect to this MongoDB server with our application. To do that, I'm going to use a package called Mongoose. So I'm going to install Mongoose, npm install Mongoose. So Mongoose is an ORM, just like SQLize. We use SQLize when we are dealing with MySQL databases. So we use Mongoose when we are developing with MongoDB databases. Alright, so Mongoose is installed. And yeah, in our application file, this app.ts file, let's write a function to connect to database. So here I'm going to create a new function, const, I'm going to name that connect to database, and it should be an async function, just like this. Oops. Alright, so here I'm going to add a try catch block. So just in case our database connection is failed, need to fall back safely. So inside this try block, I'm going to use a wait, and first let's import Mongoose to this file. Import Mongoose. So make sure you import Mongoose like this to your app file, and then I can use mongoose.connect. So as the first argument of this function, I'm going to pass the connection string of my database. So the connection is the connection string is the one that we saw here. This one, MongoDB localhost and the port. So I'm going to pass that as the first argument, and this is the connection string for just the MongoDB server. So if we want to connect to a specific databases, we need to include that as well in the connection string. So we don't have any databases yet that we have created. We can simply add the database name here, income system, and so we can simply include the database name here like this. So whenever we are running a database operation, MongoDB will automatically create the database for us. Alright, so as the second argument, we need to pass some options. Yeah, for this I'm going to just copy these options from their website. Yeah, just like this. So here as the options, we pass this new URL parser as true, and also this use unified topology as true. Alright, so we use this connect function to connect to our database. So if we reach this line of code, which means our database connection is success, I'm gonna add a console log here, console.log, and I'm gonna type db connection successful. Alright, or else if it reaches this catch block, which means the database connection is failed. And also I'm going to add this line so it will exit the process. process.exit, just like this. Alright, so we defined our function. Now we need to call it. So I'm going to use an anonymous function here. It should be an async function, just like this. So I'm going to use this await keyword and our database connect function. Alright, so just like this. And now we can simply start our application and let's see what happens. Yep, and it says that our application is running on this port, and also it says the database connection is successful. Alright, so we have successfully connected to our database server with our application. And before winding up this video, what I'm going to do is, as we have just hard coded this database URL, it's not a good practice. We need to include these database credentials and stuff inside our env file. So I'm going to create a new file inside my root directory, env. It should be .env, and here we need to define these database URLs in our env file. So as the first one, I'm going to add app name. Maybe it should be commerce system, and as the second one, I'm going to type db URI. Just like this. And to access this env file, we need to install one other package. It's called .env. I'm going to install npm install .env. Yeah. And so here what I'm going to do is, I'm going to create a new folder called config, and inside that I'm going to create a new file called index.ts. So this is where I'm going to import all my env values, and I'm creating an object so that we can simply use this object anywhere in our project without having to import this env file and also our .env package. So it's easier for us to just use this config object. So first I'm going to import .env package. Just like this, and then I'm going to use this .env function .config, just like this. And then let's define a const. I'm going to name that configs. Alright, so as the first field, the first one we define here is an app name. It should be something we are getting from our env file, process.env, and then the app name field. And let's add the fallback value as well. Just in case this value is not present on env file, we need a default value here, like this. And as the second one, let's add something called db, and here we have to define few fields. URI, for the URI, let's add process.env db URI, just like this. And let's add another field called mongoose options. just like this. So we can simply put these options there. Yeah, just like this. So we can now simply import our config object we just created here in our index file. So as the URL, I'm just going to type configs. I need to import that config file first to our app file. Import configs from, by the way, we need to export this config object first from this file. We haven't done it. Export default configs. Alright, so we here export our config file. Now we can simply import it. Import configs from configs, just like this. And here, instead of hard coding our database URI, we can simply use our configs object dot db dot URI, and as the second argument we can simply pass configs dot db dot mongoose options. I think we have an error here because let me check. Yeah, as the database URI, we need to add a fallback value as well. And now the error is gone. Alright, so let's open our terminal again and let's try. Let's restart our application and let's see what happens. Yeah, we have successfully connected to our database again with our env file values. By the way, I think we have two warnings here saying that this new URL parser and this use unified topology options are deprecated. So I think as we are using this newest version, we don't need to include these options here. We can simply remove it, and as the second argument, let's just leave it like this. Yeah, I think now the warning is gone. Let's restart our application. Yes, now the warning is gone. Alright, so now we have successfully connected to our database with our application. So before winding up this video, let's add a Git repository to our application, and so that we can push our code to our GitHub repo every time we finish a tutorial. I'm gonna type git init, and it will initialize a Git repository. Alright, so we initialized our Git repository, and now I'm going to add the git ignore file and add some files to this git ignore file. Git ignore. We can add some files and folders that we don't want Git to track. We don't need node modules folder, and also we don't need this env file, and also we don't need this idea directory created by our WebStorm IDE. Alright, so these three folders and files are added to git ignore, so they are not tracked. Alright, let's open up the terminal and let's see git status. So only these files are getting tracked by git. Alright, so let's add these files by typing it add dot this period mark, and alright, so we have staged our files and git commit and add the message saying initial commit. Alright, so and let's create a Git repository on our GitHub account. So this is my GitHub account and I'm going to create a new repository. Let's say e-commerce system Mongo. Yeah, I'm gonna keep the description blank and it should be a public repository. And yeah, I'm not adding a readme file. And yeah, let's create repository. And now let's run this command to add a remote to our Git repository. Just like this. And now we can simply push our repo to GitHub. By the way, the default branch of GitHub is main, but the default branch of Git is still master. So let's change that as master and run this command and it will push to our repo. Yeah, and if you refresh it, now our files are now available in our GitHub repo. So you can simply follow along with me by cloning this repo. So we have done quite a lot in this tutorial. We initialized a Node.js project and we initialized TypeScript and we installed Express. We created our application with Express and we created our project structure and we created routes and also we connected to database and we learned what is the database schema that we are going to develop here in our application. And finally, we added an env file by using .env package. And finally, we initialized a Git repo and pushed our files to GitHub. Alright, so now we have a nice platform to continue developing our application throughout this tutorial series. Alright, so that's the end of the part 1 of tutorial series building an e-commerce REST API with NodeJS and MongoDB. In the next video, we're going to implement the authentication module and do some serious business. Alright, so I hope you enjoyed the video. Hit the subscribe button if you haven't already and I'll see you guys very soon in the next video.